Hi class, this is our second lesson in symmetry, lesson 1.9b, and what you're seeing right now is the answers to Tuesday's homework on page 11 in the packet. Now you can hit pause here to check your homework answers to this answer key. I'll move it down a little so you can see the answer to number 9 a little more clearly. And what I recommend is that on page 11, you circle the problems that you got wrong or still don't understand to ask me on Monday, because as you remember, we have our quiz on Tuesday. Tonight's homework is pages 15 and 16 in the packet, 17 and 18, or if you're done with 15 and 16 in class and need extra practice with the studying. So as we do today's lesson, we're going to be doing symmetry about the x-axis, the y-axis, and the origin. We'll start with our graphs. A quick sketch of y equals x squared. Another quick sketch of x equals y squared. And then another sketch of y equals x cubed. You can see from the first graph, that's x-axis symmetry. Second graph, x equals y squared, x-axis symmetry. And lastly, the cubic is symmetric about the origin. Please pause the video here if students need to write this down. So as we did with odd and even symmetry, which is what we did in our last lesson, we are going to algebraically be testing for x-axis and y-axis symmetry. So when we are testing for y-axis symmetry, we're going to replace every x with negative x and see if we get the same equation. So starting with number 4. Everywhere I have an x, I'm going to substitute with negative x. So I've got negative x in parentheses squared plus 3. When I square a negative, I get a positive. The ending equation is the same as what I began with. So we can say that this is a graph with y-axis symmetry. So that was just y-axis symmetry. We also should test for x-axis symmetry. Hope I have the new color there. So everywhere that I have a y, I'm going to put negative y to see if the same equation is also symmetrical about the x-axis. So negative y equals x squared plus 3. Remember, I am not changing the x, just the y this time. So I can never have an equation that equals negative y, so that means I have to multiply both sides of the equation by negative 1 so that I can get y equals, because negative 1 times negative y is positive y. And then I have negative x squared minus 3. And even if I factored out the negative 1 or never multiplied it in the first place, we can see that our beginning equation is not the same as our ending equation, so that there is no x-axis symmetry. Next equation, we'll substitute negative x first. Negative x squared plus y squared equals 4. Remember, we're doing negative x first for y-axis symmetry. Negative x times negative x is positive x. I end up with the same equation that I started with. So I can say, yes, there is y-axis symmetry. As for our symmetry about the x-axis, x squared plus negative y as our substitution this time. Negative y times negative y is positive y squared. Again, it's the same equation. So yes, we also have x-axis symmetry. You can pause the video here if students haven't finished writing this down. Just a little blurb on point symmetry. Actually, I'll do it on the next page. Not that far. There we go. So point symmetry is when I have 2 points that are symmetric with respect to a point Q. So if you remember all the way back from geometry, point P would be our pre-image, and P1, or sometimes it's also called P prime, is our image. So this is what ends up after we've transformed something. And we know that these 2 points, the pre-image and the image, are symmetric with respect to some point Q. When they're the same distance from point Q, and all 3 points are on a line, if you remember also from geometry, we call that collinear. P1 or P prime is said to be the image of P. A figure or set of points is symmetric with respect to a point when the image of each point on the set is also in the set. So all that's basically telling me is I need to have a figure that has 3 points, Q in the middle, P, the pre-image, and P prime or P1 on the same graph. And I am able to basically draw a line through the image that hits all 3 points, making them collinear. So we would say this one definitely has point symmetry. So this one is a yes. This one, I think you can also see that no matter where I put P, the pre-image, or P prime, the image, when I draw a line, no matter where I put the points, well, I didn't hit that exactly right, but let's just stretch that a little bit. No matter where I put P and P prime, I'm going to go through all 3 points with a collinear line. So this is also yes, point symmetry. No matter how I draw these points on the parabola, that's our image, that's our pre-image. There is no way to make all 3 of these points collinear. So we would say this one does not have point symmetry. Sorry, that's my dryer if you can hear it in the background. Okay, our last test is going to be for origin symmetry. And when we test for origin symmetry, we're going to replace both x with negative x and y with negative y to test algebraically in the equation. So starting with number 9, rather than y, I'm substituting negative y. For x, I'm substituting negative x. Negative y multiplied is y squared. Negative x times negative x is x squared. The equations are the same, so we can say yes, origin symmetry. For our second equation, negative y is substituted for y, and negative x is substituted for x. Negative y equals x squared. I need to multiply both sides of this equation by negative 1 because every equation must end up with y equals. So y equals negative x squared. These are not the same, so there is no origin symmetry. Next two, y equals x cubed. Negative y substituted for y. Negative x substituted for x. Negative x times negative x is positive x times negative x makes this negative x cubed equals negative y cubed. I can multiply both sides by -1. Because of the golden rule of algebra, I end up with y equals x cubed. The equation is the same, so I've proven algebraically that there is origin symmetry. Last equation. 1/2, that's a strange color, negative y squared plus negative x equals 3/4. 1/2 y squared, positive times negative is negative. I do not think that there is any way I could rearrange this to make it look like my original equation. So I'm going to say no origin symmetry. So just a quick review of yesterday and today's lesson. An even function has obviously even symmetry, but that's going to be the same as y-axis symmetry. So the symmetry we tested for even is the same as y-axis symmetry. So if a function is even, it's automatically going to have y-axis symmetry. For an odd function, which we also did on Tuesday, anything that has odd symmetry is also going to be symmetrical to the origin. So really the only thing new that we learned today was x-axis symmetry, and that doesn't correlate with what we did previously for our symmetry, our origin symmetry, or I'm sorry, our even odd symmetry. Lastly, we're just going to do ordered pairs and just do our reflections, since we're doing all kinds of graphs and symmetry with regards to our parabolas and our cubic functions. So we're going to start with reflections of point AB. And if you remember again from geometry, quadrant 1, quadrant 2, quadrant 3, quadrant 4, and each of these different kinds of reflections move it between quadrants. So point AB is positive, positive. That point's going to be in the first quadrant. When I make B negative, if you think about B in terms of our XY coordinate, this would be our x-axis. So this would be our A, or our first in our coordinate pair. This is our y-axis, so this would be B. It says for this first point, I'm going to make B negative. So if I make it negative with the same x value, that point over the x-axis is going to move to this quadrant. Now, I always start with the same point again. If I'm starting with AB and I am reflecting over the y-axis, so basically I have the same y value, but x is negative, it moves to the third quadrant. Lastly, again, I am starting from the original point, our pre-image. I am reflecting over the origin. That's going to move it to the third quadrant. Therefore, both A and B are going to be negative in that quadrant. Okay, please do the homework on the next 2 to 4 pages as practice for a quiz on Tuesday, and I will see you soon.